Okay, Wildcats, today we're looking at Thursday, April 4th, to solve exponential and log equations, part 1 on page 56. Now, we're going to use the notes from Wednesday, April 3rd to apply to Thursday, April 4th, okay? That is why the page numbers are the same. Okay, so with that, go ahead and get your notes from Wednesday, and we're going to apply them to today and start working on the examples. All right. Example 1, solve the equation using same base. Now we know from our notes, if the base are the same, the exponents are equal. So we have 1x squared is equal to 7x plus 12. Now at this point, we need to subtract 7x and subtract 12 from both sides. So 1x squared minus 7x minus 12 is equal to 0. At this point, we're going to use our calculator to solve. So we're going to go to New Document, No, Add Calculator, Menu, Algebra, Polynomial Tools, Find Roots. The degree is 2, which you can see right here, okay? And press Enter. The values are 1, -7, -12. Press Enter once, twice, 3 times, and your solutions are x equals -1.42443 and 8.42443, which we're going to round as -1.4 and 8.4. So x equals -1.4 and x equals 8.4. Excuse me. All right. Now we're going to check, and we're going to start by checking x equals -1.4. Okay. So to do that, we need to plug this number back into the left side and the right side and see if they're equivalent. Okay. But we can't use the rounded number. We actually need to use this number. Okay. So we're going to do 2 raised to the parentheses -1.42443 squared. Okay. And then now we're going to plug that same number into the right side. So 2 raised to the 7 times -1.42443 plus 12. You can see that the left side equals the right side, so this checks. So we see that 4.08 is equivalent to 4.08, so it checks. So now let's check x equals 8.4. Okay, so to do that, we're going to use a calculator. So we're going to do 2 raised to the parentheses, and again, we have to use the entire number, so 8.42443 squared, and then 2 raised to the 7 times 8.42443 plus 12. You can see that they're equivalent, so they check. So 2.31 equals 2.31, so it checks. Okay, let's take a look at example 2. Now, example 2, we need to make them the same base. So we need to make 8 with the base of 2. To do that, well, we know that 2/3 is 8. So we need to replace 8 with 2/3. So that's 2 to the 3x equal to 2x plus 6. Now the bases are the same. We can say the exponents are equal. So 3x equal to 1x plus 6. We're going to solve for x, so we're going to subtract 1x from both sides. So we get 2x equals 6. We're going to divide 2 by both sides. So x equals 3. Okay, So now let's check x equals 3. So to do that, we're going to plug that number back into the left side and right side. So 8 to the third power equals 2 to the 3 plus 6. Well, 8 to the third power is 512. And 2 to the ninth power is 512. So this checks. Okay, go ahead and finish up example 1 and 2. All right, now let's take a look at example 3. Now, solve the equation by taking the log of both sides. So what we're going to do is we're going to take the log of base 3 of 3 to the 2x. Now, what you do to one side, you have to do to the other. So log base 3 of 25. Okay. Now, the reason we do that is because log base 3 of 3 becomes 1. So you have 2x equals log base 3 of 25. Okay. We're going to divide 2 by both sides. So x equals log base 3 log base 3 of 25 divided by 2. And you're going to leave that as is. Okay, now to check, we're going to use our calculator, and we're going to plug this in for the x. We're going to check Okay, so to do that, we're going to use our calculator. So let's delete the previous problem. So we're going to do 3 raised to the 2, and we need to put parentheses, log, control, log of 3 to 25. And actually, let me delete that. Parentheses, we need to do control divide first. Control log base 3 of 25 divided by 2. We can see here is 25. So 25 equals 25. So this checks. Okay. Now let's take a look at example 3. Same concept. We're going to take log base 5 of both sides. So that's log base 5 of 5 to the x minus 2 equals, and again, what you do to one side, you have to do this. So log base 5 of 200 okay, this becomes 1, so you're left with x minus 2 equals log base 5 of 200. We're going to add 2 to both sides. So x equals log base 5 of 200 plus 2. And we're going to leave our answer. Okay, so now we need to check. And I'm just going to put x equals. There's no space, but we know that the x equals is this x equals what we're checking. We're going to plug this in for x. Now that seems complicated, but we have our calculator, so we're going to do that, okay? So let me delete the previous problem. So we do 5 up key, and now parentheses, control divide, control log base 5 of 200. Oh, actually, we don't need control divide, sorry. For some reason, I was thinking that was a divided by 5, but that's not. That's just base 5. So control log of 5, 200, plus 2, and then minus 2, we can see here is 200. So it checks. So 200 equals 200. So it checks. Okay. All right, now let's take a look at example 5. It says solve the equation by using the log properties. All right, so let me go ahead and just give you the log properties that you'll need to assist you. So if we have log of A plus log of B, that is equivalent to log of A times B. Okay, and the other one you would need possibly is log of A minus log of B is equivalent to log of A divided by B. Okay, so those are the only two properties you really need to worry about for example 5 and 6. Now it looks like example 5 applies to this property here. So that means this becomes, now if there's no base, we assume the base is 10. Okay, log base 10. Okay, so log base 10, since we're subtracting, we divide, so that's log base 10 of 45x divided by 3 equals 1. Okay, now what we're going to do is we're going to raise both sides by 10, or make the base 10, say it better that way. So this base is 10, and this base is 10. The reason is 10 raised to the log base 10 becomes 1. So you're left with 45x divided by 3 is 15x equals 10 to the first power, which is 10. Okay, we're going to divide 15 by both sides. So x equals 10 divided by 15, which reduces to 2/3. Okay, now check, we're going to use our calculator. So we're going to check the x equals 2/3. Okay, so to do that, going to new document, no, add calculator. So we're going to do control log base 10 of 45 times, let's do parentheses, 2 divided by 3 minus log base 10 of 3 is 1. So we see that 1 equals 1. So this checks. All right, let's take a look at example 6. Okay, now here it looks like since we're adding, so it's going to be multiplication. And again, if there's no base, we assume it's base 10. So then that's log base 10 of x times x plus 9 equals 1. Now, just like example 5, we're going to make the base 10. And remember, what you do to one side, you have to do to the other. Now, 10 raised to the log base 10 becomes 1. And now we follow this. X times x is 1x squared. X times 9 is plus 9x equal to 10 to the first power is 10. Okay, now we're going to subtract 10 from both sides. So we get 1x squared plus 9x minus 10 equal to 0. At this point, we're going to use our calculator to solve. So we're going to go to Menu, Algebra, Polynomial Tools, find roots of a polynomial. The degree is 2, so press Enter. The numbers are 1, 9, negative 10. Press Enter once, twice, 3 times. So x equals negative 10 and x equals 1. All right, at this point we need to check. So let's check x equals negative 10 first. So again, we're going to plug negative 10 in for x. So control log base 10 of negative 10 plus control log base 10 of negative 10 plus 9. We get an error. So an error does not equal 1. So we know that negative 10 is an extraneous solution, which we'll abbreviate EXTSOL. Okay, so now let's check x equals 1. Now, to save yourself time, what I'm going to do is I'm going to highlight this, and where I see the negative 10, I'm going to change it to a positive 1. You can see here that 1 equals 1, so it checks. All right, let's take a look at example 7. It says solve the equation by making it exponential. Okay, now let me give you the notes that you're going to need to apply this. Okay, now the log will right here and the exponential will right here. Okay, now the log will be log base B. Let's just make that a capital B so it's easy to read. Log base B. And let me check my notes real quick to make sure I tell you this correctly. So log base B of A equals X, that's the log, okay, is equivalent to B to the X equals A. Okay, so what we have to do is understand what is what. So here the B equals 4, the A equals X squared, and the X equals 7. Now we know what B, A, and X are. We're going to apply it to the exponential form. So the B is 4, so that's 4 raised to the X, which is 7, so 4 to the 7th equals the A, which is X squared. Okay, so now 4 to the 7th is 1,000, and I'm going to rewrite this as X squared equals 4 to the 7th. It's just easier to have the X on the left. So X squared equals 4 to the 7th power is 1,000 or 16,384. Okay. Now to solve for x, we're going to take the square root of both sides. But remember, square root's plus or minus, so you have two answers. So x equals and x equals. Okay, so let's do that. Let's take the square root of 16,384. So control square root, and I can actually highlight that number, press enter. So your answer is x equals plus 128 and x equals minus 128. Okay, so now we need to check. Okay, so let's check x equals, let's do positive 128 first. Okay, so now we need to do log, and actually use the Caesar calculator. We're going to plug 128 in for x. Let's clear this out. So control log base 4 of 128 squared is 7, so we can see that 7 equals 7, so this checks. Okay. Now let's check x equals negative 128. Okay. So again, we use a calculator. So control log base 4. Now, whenever you square a negative number, it needs to be in parentheses. So parentheses negative 128 squared, we get 7. So we see that 7 equals 7, so it checks. Okay, now let's take a look at the last example, example 8. Now, we want to identify what b, a, and x are. So here, b is 3, a is x minus 5, and x equals 2. So now we're going to apply that to this form. So b is that's 3, the x is 2, equals a, which is x minus, or 1x minus 5. Now, 3 to the second power is 8. Oh, I'm sorry. 3 to the second power is 9. I don't know where I was thinking about that. But I'm going to rewrite this so the x is on the left. So I'm going to rewrite it as 1x minus 5 equals 9. Now we add 5 to both sides. So 1x equals 14. Okay? So now let's check x equals 14. Now, what I've been doing is just plugging in the number to the left side to verify it's the right number, but there's another way to do that. It's just plugging in all as one sentence. So, delete this, and we're going to put control log base 3 of 14 minus 5, and I'm actually going to put equals 2. This is another way you can check. When I press enter, it's true. Okay, so we can write log base 3 of 14 minus 5 equals 2, and a little note that that's true, so it checks. Okay, so with that, if you would, start working on your assignment and have a wonderful Wildcat day.